Hello everyone. I am very happy to study the aircraft construction course with you. I am Zhang Qiyuan. Let's explore the structure of the wing and the tail section of the aircraft together. In this issue, we focus on the structure of the wing and the tail section of the aircraft. Part 1. Wing structures. There are three main functions of the wing. First, generate lift and hold the aircraft in flight. Second is the fuel tank of the aircraft, storing fuel and installing a fuel system. Third, as a mounting platform, it serves as a base for key systems such as the engines and the flight controls. From the evolutionary history of the wing, in order to increase the lift of early aircraft, double-layer or even three-layer wings were used. Modern aircraft all adopt a single wing design. There are three categories by location. Upper single wing maximize the space utilization of the fuselage. The low wing monoplane offers minimal air resistance and provides the most convenient location for installing the landing gear. Low engine position, easy to maintain. Do you know which configuration of wings is most conducive to emergency escape? In 2009, US Airways Flight 1549 made an emergency landing on the river due to twin-engine failures. It was a miracle that 155 passengers and crew members successfully escaped from the wing. The wing body consists of three major blocks: the left wing, plus the center wing, plus the right wing. Their internal components are docked one by one, forming a tight hull, and the flight load is transmitted to the fuselage. The left and right wing boxes are the exposed parts of the wings we usually see. The front root spars are used as tank sidewalls, mating ribs, stringers, and upper and lower skins partition the interior of the wing into separate fuel tanks. Note that the upper and lower skins have different divisions of labor. Aluminum zinc alloy for upper skin, red mark, mainly responsible for resisting compression force. Aluminum copper alloy for lower skin, green mark, mainly responsible for withstanding tensile force. The lower skin also has access to maintenance. The front and rear spars are connected to the skin by rivet bolts, and the closer they are to the wing tips, the thinner they are. The muscles of the front spars are special. See inside. Verticals, thinnest, are like reinforcement nets connecting webs, then lock the ribs through the edges. This combination greatly improves the rigidity. The rear spar structure is similar, but it has a strong partner, landing gear support, arm fourth rear beam, to help it share the landing impact. The leading edge structure is composed of a front beam, thinnest ribs, and upper and lower skins, which provide support for the flap and slat structures. The trailing edge structure consists of wing ribs, thinnest rear beams, and upper and lower skins, which provide support for flight controls, aircraft system equipment, oil pipes, cables, and wires. Winglets have significant effects in increasing lift and reducing induced drag. The center wing box assumes three functions: transmitting the wing load to the fuselage, storing fuel as a fuel tank, and providing a connection fulcrum for the left and right wing boxes. Its structure consists of front, rear spars, upper and lower skins, and stringer. The outer boundary is formed by fuselage ribs at the fuselage wing junction, which simultaneously define the inner end faces of the left and right wing boxes. The skin is reinforced cooperatively with the left and right skins through a two-way extended stringer, and at the same time, the overall rigidity is strengthened by the reinforced web vertically connected between the upper and lower skins. Part 2. Aircraft tail section structure. The tail section is non-pressurized and contains vertical stabilizer plus rudder, horizontal stabilizer plus elevator, and the tail compartment. The tail compartment is riveted with a bulkhead stringer, and the APU can be placed inside with access doors and exclusive intake and exhaust. The function of the horizontal stabilizer is to maintain longitudinal balance and perform pitch trim control, as well as install elevators. In addition, it can also be used as a trim fuel tank on certain aircraft, such as the Airbus A380. The structure of the horizontal stabilizer is divided into two schools: unitary rotary display, integrally formed structural box, plus movable leading edge, plus hinge elevators. Three-piece type split demonstration. The left and right side sections include torque boxes, and the middle section transmits force to the fuselage. The vertical stabilizer looks like a standing wing. The front and rear torque boxes, plus leading edges, plus fin tips constitute the main body, which can maintain the directional stability of the aircraft. The rudder is hinged on the trailing edge of the vertical stabilizer to control the yaw of the aircraft. The fin tips are smoothly connected to the fuselage in a streamlined shape. Thank you for studying. Now comes the exercise session. Students can press the pause button to think and answer. Let's start now. Have all the students answered correctly?